Let's learn more about metals. So a metallic bond, this is cation surrounded by a sea of delocalized electrons, and it's called the electron sea model. And there's two types of metals down here. We have one metal that just has one delocalized electron, and then we have another metal that has two delocalized electrons. Hardness in metals is based on the number of delocalized electrons. The reason why alkali metals are so soft is they only have one valence electron, and so only that one valence electron can become delocalized. In your alkaline earth metal family, two electrons can be delocalized, as with a lot of the transition metals, because they have two valence electrons. But transition metals do something special in that they delocalize their d electrons. Not all of them do, but a lot of them do. And so that's why you have different oxidation states, and you also have the hardest metals come from the transition metals. The physical properties of metals, they are all relate to these delocalized electrons. They have high melting points and boiling points. They have electrical conductivity, and that is because the electrons are free to move and carry a current. They have thermal conductivity. Again, it's the delocalized electrons that can carry the heat. And they are malleable and ductile. So ductility means you can pull it into a wire. So down in the lower right-hand corner, we have stretching a substance. And some metals, they stretch into a wire easier than others. And if you do pull too hard, you can break it, like in A. But gently stretching it through a smaller hole is usually what you do. You can pull it out into a wire. Metal alloys. The AP Chem test is big on metal alloys. You for sure need to know these two different types and what they mean. A substitutional alloy, this is when some of the atoms in the metal are replaced with another metal atom of a similar size. And a good example of this is with brass. Brass is made up of copper and zinc. And so here you can see in the picture on the right hand side, you have copper atoms, and those zinc atoms are spaced here and there, and they will cause a hardness as one of the properties brass will have. See, it's a substitutional alloy because they're a similar size. An interstitial alloy, this is when some of the little spaces in between those metal cations, they are filled with a smaller atom. And it could be carbon, it could be boron, so something that's really, really small and can fit in that space. And why alloys? Because it increases the hardness. With an alloy, you get properties of both metals when you melt them together to make an alloy, and so it makes a better metal. Especially with the interstitial alloy, its strength comes from the metal cations not being able to slide as well. So in steel, it's super hard because the carbon atoms, they block the ability to slide around. And this is what this picture is trying to show. So if you have a force, that metal will bend because it's malleable, but if you have an alloy and you put a force on it, it's less likely to bend, and that is because it doesn't slide as easily. Here are some different pictures of different types of alloy. So substitutional alloy, sterling silver. It is made up of silver and a little bit of copper, and it is substitutional. When you look on the periodic table, you see that copper and silver, they're right on top of each other. The silver will be a little bit larger, but it is roughly the same size. And then brass was the example from the slide before, carbon and the zinc. You see that they are right next to each other on the periodic table. There are different recipes for different percentages for alloys, nothing that's really set in stone, so to speak. But sterling silver, there's the percentages there, and brass, it differs greatly. So you might have more zinc to make it more harder, or have less zinc to make it softer. Just kind of depends on what you're doing with your brass. Interstitial, again, that is when you have a really small atom that you mix with a larger atom, and it causes the metal to be harder because it can't bend as easily. In some case, alloy formation alters the chemistry on the surface, and a good example of this is stainless steel. So when you look at stainless steel, you have an alloy of iron and carbon and chromium, and then you have a layer of chromium oxide on the surface. And if it gets dinged or gouged, you actually have a reaction between the chromium that's in the alloy. It will react with the oxygen and it will make a new chromium oxide layer. And so that way it doesn't rust.